The bag's in the garage. You tear it open, tip the briquettes into the grill, and a few minutes later, the coals are glowing, and the whole backyard smells like summer. It happens so easily it barely registers, but those small black pillows did not come from nature. Nobody found them on the ground. They were not chipped from a tree. They were designed, ingredient by ingredient, to burn at a specific temperature for a specific length of time, in a way that raw wood never could. How exactly does wood waste become that? How do sawdust and agricultural scraps become a uniform fuel block that performs the same way every single time? The real answer starts not with a bag on a shelf, but with Henry Ford, a pile of wood offcuts, and a waste problem he needed to solve. Let's get right into it here on Small Things. Not burned wood, engineered fuel. Pick up a briquette. It's dense, smooth-edged, almost perfectly uniform. Every one in the bag is the same shape, the same weight, roughly the same hardness. That consistency is not an accident, it's the whole point. A briquette is not a chunk of charcoal broken from a larger piece. It's a manufactured object. Charcoal powder mixed with binders and additives pressed into a mold, dried until it hardens. Natural lump charcoal is closer to the source. It burns hot, but unevenly. Pieces vary in size, some catching fast, some slow. A briquette was designed to solve all of that. Same ignition, same burn rate, same heat output. Reliable and repeatable for anyone who just wants the food to cook properly. From Ford's factory floor to your grill. It did not begin as a cooking product. It began as a waste problem. Henry Ford was not just building cars. By the early 1920s, his plant in Michigan was consuming enormous quantities of wood for the frames and floorboards of the Model T. The sawmills producing that wood were generating mountains of sawdust, chips, and offcuts. None of it had a use. All of it was costing money to deal with, and Ford hated waste more than almost anything. His solution came through a conversation with his brother-in-law, E.G. Kingsford, who identified a plot of land in Michigan with good timber access and a rail connection. Ford built a wood distillation plant there, designed to convert wood waste into charcoal and other usable byproducts. The charcoal was pressed into briquettes and sold under the Ford name at Ford dealerships across the country. Customers buying a Model T could, for the first time, also pick up a bag of charcoal for the garden grill on their way out. The venture worked well enough that Ford eventually sold the business. It was renamed after the man who had helped set it up. That's why the dominant brand of charcoal briquettes in America is called Kingsford. What began as a factory waste problem became one of the most recognized names in backyard cooking. But the commercial story is only part of it. The real innovation was the manufacturing method Ford's engineers developed, the process of turning loose charcoal powder into a consistent, uniform fuel block. That method proved durable enough to remain the foundation of briquette production nearly a century later. Before Ford's approach, charcoal for cooking came in irregular natural lumps. You used whatever the bag gave you. Some pieces were dense and slow burning, others were light and gone in minutes. The backyard grill, as we know it, the weekend ritual of controlled, predictable heat, was only really possible once someone engineered the fuel. Ford did not set out to change the way the world grills. He was trying to clear the rubbish off his factory floor. The fact that those two things ended up being the same project is exactly the kind of story that makes ordinary objects so much more interesting than they appear. He solved one problem and accidentally created a summer tradition. The journey from waste to heat. So what actually happens between a pile of wood scraps and a finished briquette? It starts with something close to fire, but not quite. The raw material can be almost any woody biomass: sawdust, wood chips, offcuts from furniture factories, rice husks, coconut shells, whatever is available. This goes into a carbonization kiln, heated to about 400 and 700 degrees Celsius in a low oxygen environment. Without enough oxygen, the wood cannot combust. Instead, it decomposes. Water, tar, and volatile gases are driven off. What remains is a porous structure of almost pure carbon, not burned, transformed. Once cooled, the charcoal is crushed into fine powder. This powder burns beautifully, but you cannot pick it up. It falls apart. Left in powder form, it is useless as fuel. So it gets mixed. Starch made from corn, cassava, or wheat is added as a binder, along with water. Limestone or clay goes in to regulate the burn rate. A small amount of an oxidizing agent helps the finished briquette ignite reliably. The result is a thick black paste, nothing like the finished product, closer in texture to dough. That paste goes into a briquetting press. The familiar pillow shape is formed by pressing the mixture between two rotating molds under high pressure. In a fraction of a second, paste becomes form. Hexagonal briquettes are made differently, pushed through an extrusion die, forming a rod with a hole through its center, then cut to length. That hole is not decorative. It channels air through the burning briquette, helping it stay lit longer and burn more evenly than a solid block would. Fresh briquettes are still wet and fragile. They move through drying ovens where circulating hot air reduces moisture to around 5%. As they dry, they harden. What went in as paste comes out as solid, stackable fuel. Then they're screened, packaged, sealed, and shipped. The whole journey from waste wood to bag on a shelf is complete, and none of it looks anything like what it started as. Lump charcoal is not simpler. Most people who care about grilling have an opinion on lump charcoal versus briquettes, and that opinion usually involves lump charcoal being the purer, more natural choice. The story is more complicated than that. Lump charcoal is, in one sense, more direct. It is wood that has been carbonized and broken into pieces without any additional processing. No binders, no additives, no pressing. If simplicity in ingredients is what you value, lump charcoal wins. But simplicity in ingredients does not mean simplicity in performance. Lump charcoal burns hotter, yes, but it burns unevenly. Large pieces catch slowly. Small pieces burn out fast. The temperature across a bed of lump charcoal fluctuates in ways that matter when you're trying to cook something specific. Controlling a lump charcoal fire takes experience and attention. A briquette was built for the opposite. The additives that some people consider impurities are doing real work. The binder holds the charcoal particles in a consistent density. The limestone regulates how quickly the fuel oxidizes. The shape, whether pillow or hexagonal, determines how air moves around and through the fuel as it burns. These are not compromises, they're engineering decisions made to produce a predictable result. The irony is that the less natural option was designed to give more people more control over their fire. Whether that trade-off is worth it depends entirely on what you're cooking and how much attention you want to give the grill. More than a weekend ritual. Today, you'll find charcoal briquettes doing work that goes well beyond the suburban backyard. In Japan, binchotan, a dense white charcoal made traditionally from oak, is used in high-end restaurants and grilling bars where the fuel is considered part of the cooking itself, chosen for its near smokeless burn and remarkable density. The grill is not just a tool there, the charcoal is an ingredient. In parts of Africa and Asia, briquettes made from agricultural waste serve as a primary cooking fuel for millions of households, providing reliable heat from materials that would otherwise decompose in a field or be burned in the open air. The sustainability angle here is real. Rice husks, bagasse from sugarcane, coconut shells, and crop residues can all be carbonized and pressed into briquettes. In regions where cutting trees for cooking fuel is a serious pressure on the environment, this matters enormously. The same heat output, no tree felled. Manufacturing has continued to improve since Ford's Michigan plant. Binders are more refined, burn temperatures are more precisely controlled, and the hexagonal design with its central channel has become more widespread because the performance advantage is measurable. The basic process, though, carbonize, crush, bind, press, dry, has not changed in any fundamental way in nearly 100 years. Henry Ford's original insights scaled from one factory floor to a global industry. The bag on the shelf carries that whole journey quietly inside it. Design hidden in the dark. So how does wood waste become the fuel in your grill? Through heat, chemistry, pressure, and design decisions made so far upstream that most people never think to ask about them. The carbonization removes everything except the carbon. The binder gives the powder a shape it can hold. The pressing makes it uniform. The drying makes it solid. And the form determines how it will burn when the coals finally glow. A charcoal briquette is not just a piece of burned wood. It's a carefully engineered fuel designed to turn discarded wood and agricultural waste into consistent, long-lasting heat. Sometimes the simplest things are the result of far more design and precision than we realize. The next time you light the grill, you're lighting the end of a very long process. If this changed the way you think about the fuel quietly doing its job in the bottom of your grill, let us know in the comments what you want us to explore next. We might make it our next episode. Thanks for watching. History often hides in the smallest details.